सर जी ग्रुप में शेयर कर लिया लिंक.
Okay, thank you. So let's wait for 1 more minute and then we will have to start.
Sure, sir.
Zabula, can you see the screen?
Yes, sir. I can see the screen. The slide, yes, sir.
Okay, so I hope everybody can see the screen,
Yes, sir.
the slides. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. So in the last class we were talking about introduction to aggregates. So I hope you people remember this topic. Today we will be talking about classification of aggregates. So how we can classify the aggregates? So we can classify the aggregates according to petrological characteristics. Now what is petrological characteristics? So the branch of geology that studies the rocks. So on the basis of this geology, how we can classify these rocks? So I hope you remember from the first semester that we divided the rocks in the stone topic into three types. One was sedimentary rocks, the other was metamorphic rocks, and the third one was igneous rocks. So sedimentary rocks are those rocks which are formed from particles of sand, shale, pebbles, and other fragments or particles of material. So these rocks are normally formed from particles of sand, shale, pebbles, and other particles. Together, all these particles are called sediments. When all these particles are get together, then we are calling this sediments. Gradually, the sediments accumulates in layers. So all these sediments are accumulating in layers. ये तह दर तह जमा हो जाते हैं, and over a long period of time hardens into rock. And with the passage of time and long time, what happens to these particles, or to these pebbles and these shales and sands and to these sediments? It becomes hard and converts into rock. Generally, sedimentary rock is fairly soft and may break apart or crumble easily. The general classification of sedimentary rock is that it is soft and it can break and it can be converted into different parts easily. You can convert into different parts easily, or it can get crumble or it can get cracks easily. You can often see sand, pebbles, or stones in the rock. So here in this picture, you can easily see the stones, sands, and other particles in this rock. And it is usually the only type that contains fossils. So you can also see over here some coal and some other fragments inside these rocks. Example of this rock type includes conglomerate and limestone. These two types are presenting sedimentary rocks, that is conglomerate and limestone. These are the types of sedimentary rocks. The next topic is metamorphic rock. Metamorphic rocks are formed under the surface of the earth from the metamorphosis, or from the process in which change takes place that occurs due to intense heat and pressure, or the squeezing of these materials or these rocks take place. So metamorphic rocks are those rocks which are formed under the surface of the earth from the metamorphism or from the metamorphosis process, that occurs due to intense heat, due to very high heat and very high pressure. The rocks that result from these processes often have ribbon-like layers and may have shiny crystals. You can see in this one and also in this one, formed by minerals growing slowly over time on their surfaces. Example of this rock type include slate and marble. The third type of rocks is igneous rocks. Igneous rocks are formed when magma, that is the molten rock deep within the earth, cools and hardens. Now, where we can get these igneous rocks? Igneous rocks, these come from the magma when the molten rock deep inside the earth cools and becomes hard. Sometimes the magma cools inside the earth, and other times it erupts onto the surface from volcanoes. When it erupts and comes to the surface, then it is called lava. When this lava cools very quickly, no crystals are formed and the rock looks shiny and glass-like. Sometimes gas bubbles are also trapped in the rock during the cooling process, leaving tiny holes or small holes and spaces in the rock, which makes these rocks as lightweight aggregate as well, which we will study in the aggregate topics, that how lightweight aggregates are formed. Example of this rock type include basalt. I hope everybody remember this from the first semester. This is the igneous rocks, sedimentary rocks, and metamorphic rocks. Zabullah,
Yes, sir.
everything is okay?
Yes, sir. Everything is okay.
Okay. The next one is
सर
the
ये
next classification is
कॉन्ग्लोमेरेट सर ये आर्टिफिशियल स्टोन की टाइप में नहीं आता
जी बेटा
सर ये कंग्लोमेरेट जो ये आर्टिफिशियल स्टोन की कैटेगरी में नहीं आता जो आपने इग्नियस रॉक में जो सेडिमेंट्री रॉक में बताया
uh, this one conglomerate and limestone.
यस सर
How you can say this?
सर मैंने पूछा मैंने कहा सर कि ये आर्टिफिशियल स्टोन को हम वो कंग्लोमेरेट तो आर्टिफिशियल स्टोन होता है सर के नहीं
कैसे
मे बी
होता
आई
है?
एम
How
रॉन्ग
you
सर
can जी
सर नाम सुना था मैंने लिखा भी था सर
जी
मैं देख के आपसे शेयर करता हूँ सर
okay so okay already I hope we have discussed these types and later on we can discuss this again when we will be talking about these artificial stones as well. We have this in our today lecture, this artificial stone as well. Yeah, if you remember, we have discussed this and the natural aggregates and artificial aggregates. This was artificial aggregates. So where it is written, beta?
सर वो फर्स्ट सेमेस्टर में जब हमने आर्टिफिशियल स्टोन पढ़ा था मैं भी इस तरह का सेम कोई और नाम हो मैं चेक करता हूँ सर फिर आप अपना वो कंटिन्यू करें
ठीक है बेटा, when you are asking such questions, please make sure that you are asking the right questions. Okay. Now, according to weight, how we can classify the aggregates according to the weight. So we have heavy weight aggregates, we have normal weight aggregates, and we have lightweight aggregates. No, so the first one is the heavy weight aggregates. The aggregates having the bulk density more than 2080 kilogram per cubic meter are called heavyweight aggregates. So I hope you people will have to remember this. When the aggregates bulk density, that is the total weight divided by the total volume. The total volume is that in which we are also taking the volume of the voids is equal to is more than 2080 kilogram per cubic meter. Then we are calling this aggregate as heavyweight aggregates. Heavyweight aggregates include hematite, magnetite, barite, limonite. All these are the minerals which are coming in the heavyweight aggregates types. The specific gravity of heavyweight aggregate is greater than 2.8. Those aggregates with high density and is used primarily in the manufacturing of heavyweight concrete for the protection against nuclear radiation and as a bomb shelter. Where we are using these heavyweight aggregates or high density aggregates, we need this for the protection against nuclear radiation so that we can save the people who are working in the hospitals and also in the nuclear power plant, and also this can be used as bomb shelter. Radiation shields protect the operating personnel against the biological hazards in the nuclear energy industry or X-ray, gamma ray at therapy or at operation centers. Tendency of aggregate to segregate in a concrete mixture increases with the density of the aggregates. So as we discussed in the segregation process, that the coarse aggregate having more density, it will settle down quickly as compared to the normal weight aggregates or lightweight aggregates. So due to the settlement of these aggregates in the concrete, will cause segregation. The next one is the lightweight aggregate. We discussed the heavyweight aggregate. The next one is the lightweight aggregate. The lightweight of the aggregate is due to the cellular or highly porous microstructure. The lightweight of the aggregates is why we are calling it lightweight, because its cellular or it has cellular structures are highly porous microstructures. Natural lightweight aggregates are made by crushing igneous volcanic rock such as pumice, etc. As I told you in the this last type of rocks, that was uh, igneous rocks. They due to the cooling process, leaving tinish holes or small holes and spaces in the rock. So due to this process, it makes the rock as lightweight. Synthetic lightweight aggregates are manufactured by thermal treatment of a variety of materials. For instance, clay, shale, slate, diatomite, perlite, vermiculite, blast furnace slags, and fly ash. Density ranges from 1350 to 1850 kg per cubic meter of expanded perlite, burned clays having specific gravity less than 2.4. So you will have to remember for lightweight aggregates, the specific gravity of the aggregates will be less than 2.4. And its density ranges from 1350 to 1850 kg per cubic meter. Whereas for the heavyweight aggregates, it is more than 2080 kg per cubic meter, and the specific gravity is greater than 2.8. Now coming towards the normal weight aggregates, as we discussed the heavyweight aggregates in which the specific gravity is greater than 2.8, and then we discussed the lightweight aggregates in which the specific gravity is less than 2.4. So the gravel, sand, or crushed stones having specific gravity n between 2.8 and 2.4 are called normal weight aggregates. These normal weight aggregates are producing normal weight concrete having density 2200 to 2400 kg per cubic meter. The most common aggregates are sand, gravel, and crushed stones, which are normally available in the market. Now, on the basis of size, how we can classify the aggregates on the basis of size? So we can classify the aggregates into two types. One is the fine aggregate, and the other is the coarse aggregate, and it is based on the basis of size. The aggregates which passes through CU number 4 are CU having size 4.75 millimeter, and retained on CU number 200 are CU having 75 micron CU size, are known as fine aggregates. So I hope everybody will have to remember this. Those aggregate which passes from CU number 4 are 4.75 millimeter CU, and attained on CU number 200 are 75 micron CU, are known as fine aggregate. ORR, you can define it in this way as well. The size of aggregates whose size is 4.75 or less are considered as fine aggregates. The size of the aggregates, when the size of the aggregate are 4.75 millimeter or less than this, then we are calling it fine aggregate. The size of fine aggregate ranges from 2.8 millimeter to 3.1 millimeter, are known as coarse sand. When the range of the particle size is in between these sizes, then we are calling it as coarse sand. The size of fine aggregate ranges from 2.5 to 2.8, then we are calling this as medium sand. And if this range varies from 2.3 millimeter to 2.5 millimeter, then we are calling it as fine sand. So there are further three divisions on the basis of size and fine aggregate. That is the coarse sand, medium sand, and fine sand. And these are the limits. You have to remember these limits. The next one is the coarse aggregate. On the basis of size, the next type of the aggregate is coarse aggregates. The size of aggregates that are bigger than 4.75 millimeter, or you can say those aggregates which retained on sieve number 4 or 4.75 millimeter sieve, are known as coarse aggregate. Coarse aggregates is the basic material of the concrete. I hope everybody remember this. Crushed stones or gravel used in concrete are the type of coarse aggregate. Here you can see the coarse aggregates, that is the gravel or shingle and crushed stones having size greater than or equal to 5 millimeter. Typically, the size of coarse aggregate varies from 9.5 to 37.5 millimeter. Aggregates containing a whole range of particles are named as all N, all the particle size are there, or pattern gravel. I hope you remember this. I discussed this. Pattern gravels are those materials which we can get from riverbed sides, and we can directly use this in the concrete with minimal processing or with no processing. Here you can see this is the riverbed material, and these are the crushed stones. Now the factors which contribute to aggregate characteristics. So I hope you can properly understand that what are the characteristics, or what are the factors which contribute to the characteristics of the material. So the parent rock, the type of the parent rock, it can affect the properties or the characteristics of the aggregates. The microstructure, whether it has pores or it has high density. The porosity and density, as I told you, either it is porous or no, it has non-porous. Mineralogical composition, which type of minerals it has. Then the crushing strength, how much crushing strength it has. What about the abrasion resistance of these rocks or these aggregates? How much is the elastic modulus of these aggregates and what is the soundness of these aggregates. Now the properties of hardened concrete and the properties of plastic concrete. These properties or these characteristics will have to affect the properties of fresh concrete as well as the properties of hardened concrete. So how it can affect the properties of fresh concrete? It can affect the consistency or the uniformity of the concrete. It can affect the cohesiveness of the concrete. It can affect the unit weight of the concrete. Whereas in the hardened concrete, it can affect the ultimate strength. If you have good quality aggregates, you will have high strength, and if you have poor quality aggregates, then you will have lesser strength. The abrasion resistance, if you have high strength aggregates, then it will be having high abrasion resistance. Similarly, dimensional stability, there will be no shrinkage, there will be no volumetric changes in the concrete when you have good quality aggregates. Durability, the durability of the concrete will be very high if you have used good quality aggregates. Now prior exposure and processing factors. Now if you have properly the aggregates which you have used, they were exposed to the weathering actions or to the environmental effects, and then the processing factors, how you have processed this, what were the factors which has contributed in converting these aggregates or these particles into crush. Then the particles characteristics, the size, we discussed this, how the size can affect the properties of the aggregates as well as the property of the concrete. The shape of the aggregates and the texture of the aggregates, we will discuss this. Concrete mix proportioning. And finally, all these properties, all these factors, this will affect the proportioning in the concrete mix design. So what are the characteristics of aggregates? So the important characteristics of aggregates towards making concrete include the bulk density and the specific gravity of the aggregates, the moisture absorption and bulking of sand of the size, shape, and surface textures, and index, that is the fineness modulus. I will explain this in detail. Then we will then the impact, abrasion, and crushing resistance of the aggregates, elastic modulus of the aggregates, and soundness of the aggregates. All these are the characteristics of aggregates uh, which affect the qualities or which affect the properties of the concrete. So number one is the gradation of the aggregates. How the gradation of the aggregates will affect the properties of the concrete. So grading is the particle size distribution of an aggregate is determined by a sieve analysis process. So Zabullah, have you performed this sieve analysis in the laboratory? Zabullah, Harun Khan, Harun Khan,
Yes, sir.
Muhammad Atif. Have you people performed
Yes,
this
sir.
sieve analysis in the laboratory?
Yes, sir. Yes, sir.
सर
So
हमने
I
इसको
hope you know about. जी
देखा
बेटा,
है सर, सर ये वीडियोस की उसमें देखा हुआ है, लेकिन ये प्रैक्टिकली परफॉर्म नहीं किया.
critically perform nahi kiya. If you remember, I showed you the different type of sieves in the class. Do you remember those sieves?
यस सर, बिल्कुल याद है सर.
याद है? अगर याद नहीं है
जी
तो
सर,
वहां पे
बिल्कुल याद
आई
है.
आस्क यू वन क्वेश्चन, पराठा कौन बना सकता है? अभी याद आ गया? वहां पे मैंने एक क्वेश्चन पूछा था सबसे कि पराठा कौन बना सकता है? ये क्वेश्चन किसको याद है?
नहीं, इसके क्वेश्चन तो याद नहीं है सर.
ये वाला कमेंट याद नहीं है. Because when we are making paratha, we are passing this atta from the sieve. So that's why I asked you this question.
जी सर, बिल्कुल.
Okay, so let's go to the next point. So grading is the particle size distribution. How we can distribute the particle size of an aggregate is determined by a sieve analysis, and this is you can see the detail of this procedure in ASTM C136 document. The grading and grading limits are usually expressed as the percentage of material passing from each sieve. There are several reasons for specifying grading limits and nominal maximum aggregate size, because they affect the relative aggregate proportions as well as the cement and water requirements. It also affects the workability of the concrete. It also affects the economy of the concrete, porosity of the concrete, shrinkage of the concrete, and durability of the concrete. Okay, so that's why we need to use well-graded aggregates. So how you can get the well-graded aggregates? You can get this with the help of gradation of aggregates or with the help of sieve analysis. Variation in grading can seriously affect the uniformity of concrete from batch to batch. If you are changing the grading of aggregates from one batch of concrete to another batch of concrete, what will happen? It will seriously affect the uniformity of the concrete. In general, aggregates that do not have a large deficiency or excess of any size and give a smooth grading curve will produce the most satisfactory results. As you remember, I told you, if you have well-graded aggregates, if you have poorly graded aggregates, gap-graded aggregates, or uniformly graded aggregates. So out of all these graded aggregates, the best one is the well-graded aggregates, because it has the higher size, the medium size, the intermediate size, and the finer size. The cement paste requirement for concrete is related to the white content of the combined aggregates. If you have more white content in the aggregates, then you will need more cement paste. If you are needing more cement paste, then you are affecting the economy of the concrete. If you have less white in the concrete or in the aggregates, then you need less cement paste. When you are needing less cement paste, you are making the concrete economical. The effect of a collection of various size in reducing the total volume of whites between aggregates is illustrated by the simple method shown on next slide. Here you can see that when the beakers are filled, these are the beakers, when these are filled with one particle size of equal volume, you can see over here, these are the coarser aggregate, these are the fine aggregate, and these are the combination of this fine as well as this coarse. The white content is constant. Here you can see the white content is almost the same as over here. But when you are combining these two, you can see these are the volume of the whites. But when we are combining these two, then here you can see the volume of whites is decreasing, because these fine aggregates have occupied the volume of the whites over here, regardless of the particle size. When the two aggregate sizes are combined, the white content is decreased. If this operation were repeated with several additional sizes, a further reduction in whites would also occur. So if we are further adding such aggregates which are in between these two particle size, the reduction in the whites can further reduction in the whites will occur. The main factors governing the desired aggregate gradings are the surface area of the aggregates, which determines the amount of water necessary to wet all the solid. So I hope you people remember that when we are using small size particles, it will need more water to wet its surface because of the higher surface area. And if we are using large size particle, the maximum possible size aggregates, then we will need less water to wet the surface of these solids or these aggregates. The relative volume occupied by the aggregates, how much volume has been occupied by the aggregates, and the workability of the mix, how much is the workability of the concrete mix, and the tendency to segregation. So these are the main factors which are governing the desired aggregate grading. So if we are using well graded aggregates, we can have proper workability. We will be having minimum segregation or no segregation, and most of the volume will be occupied by the aggregates. As I told you, that 3/4 of the volume has to be occupied by the aggregates, so that you can have proper volumetric stability. Now the sieve analysis method. As I told you, we are using sieves. So this is the fine sieves. Fine sieves having finer sizes, small holes. This is the coarse sieve having larger size, large holes. And this is the sieve shaker, mechanical shaker, with the help of which you can shake the sample of the material you have placed, or you want to find the grading of that sample. So particle size distribution is determined by sieve analysis method. Sieve analysis is the name of the operation of dividing a sample of aggregates into particles, into fractions, each consisting of particles of the same size. In practice, each fraction contains particles between specific limits, these being the openings of standard test sieve. So here you can see these are the British standards. We are presenting this in millimeters. This is the American standards. We are presenting this in inches and numbers, and then these are the nominal opening in inches. Here you can see this 75 millimeter. Then we are calling it this 3-inch sieve, and here you can see the nominal opening is 3 inches. Then 37.5, it is 1.5-inch sieve, and the nominal size of the opening is 1.5 inches. Then 20 millimeter sieves, and this is 3 by 4-inch sieve, and its nominal size of the opening is 0.75. Then half-inch sieve, that is 12.5 millimeter or 0.5 inches. Then we have 1 by 4-inch sieve, that is 6.3 millimeter, and the nominal opening size is 0.25 inches. Then we have sieve number 4, which has 4.75 millimeter sieve, and this is sieve number 4. So Zabiullah, why we are calling it sieve number 4?
सर मैं बताऊं?
नहीं, Zabiullah. ये बता Zabiullah. Zabiullah, are you in the class? अपाक नवीद, शायद नवाब अपना वीडियो बंद कर दें, वेबकैम बंद कर दें. अपाक नवीद,
जी सर.
can you tell us why we are calling it sieve number 4?
Sir, I don't know.
Okay, एजाज अली शाह.
सर इसका मतलब ये, यस सर इसका मतलब ये कि हमारे पास जो 1 linear inch में नंबर ऑफ ओपनिंग्स 4 होते हैं.
जबरदस्त, good, well done beta. Okay, so in 1 linear inch there will be 4 holes or 4 wides, and number 8 in 1 linear inch there will be 8 holes, and in sieve number 200 in 1 linear inch there will be 200 holes or 200
सर ये
wides.
linear क्या मतलब है?
Linear means in one dimensional. Do you know linear in one dimension? You have this sphere, okay? This is linear. This is have you studied this in mathematics, linearity or linear functions or one dimensional functions?
जी सर, I have studied.
This is one line, okay? This is another line. So in this one line, in 1 inches there will be 1, 2, 3, 4. Let's say this is 1, 2, 3, 4. So this is 1 inch. In this 1 inch we have this one wide, 2, 3, 4. This we have 4 holes in 1 linear inch. So if you took this on the other side, like in this side, so you have just to add one more hole. So if it is 1 inch, in this 1 inch there will be 1, 2, 3, 4 holes. Okay, so this is in this direction, in this direction, or in this direction, or in this direction. Okay, so in 1 linear inch, if you are measuring 1 inch, so in 1 inch there will be four holes. Okay, this will be not in square inch, this will be in linear inch. Requirements of ASTM are: the fine aggregate must not have more than 45% retained between any two consecutive standard sieves. So these are the requirements of ASTM, that between two consecutive sieves and fine aggregates, the retained shall not be more than 45%. The fineness modulus must be not less than 2.3 nor more than 3.1. I will explain the fineness modulus, how you can calculate the fineness modulus, but for fine aggregate it varies from 2.3 to 3.1. If this value is exceeded, the fine aggregates should be rejected unless suitable adjustments are made in properties of fine and coarse aggregate. If you have got a sample on site and the value of fineness modulus is not coming in this range, then you can either reject that material, or you can add, if it is on the finer side, you can add coarser sand. If it is on the coarser side, you can add finer sand, and you can do some adjustment, and then you can allow the use of this material. Now the fineness modulus. What is fineness modulus? Of either fine or coarse aggregates according to STMC 125 is calculated by adding the cumulative percentage by mass retained on each of a specified series of sieves and divided by the sum by 100. So how we can calculate the fineness modulus? The fineness modulus is a number which we can get from the sieve analysis. And how we can get it from the sieve analysis? We have to sum up. क्या करेंगे? जमा करेंगे. We have to sum up all the cumulative percentage retained on specified sieves, and then we have to divide by it by 100. You will see this in the tabular form in the next slide. Fineness modulus is an index of the fineness of an aggregate. The higher the fineness modulus, the coarser will be the aggregate. The smaller the fineness modulus, the finer will be the aggregate. And this is the procedure how you can calculate, how we can calculate the fineness modulus of the aggregates. So here you can see these are the sieve sizes, both in millimeter and numbers. You can see 3 by 8 inches, number 4, and so on. Percentage, you will have to be careful. I will have to ask questions in this table. Here you can see the percentage of individual fraction retained by weight. Here the cumulative percentage retained by weight, and here we can see the percentage passing by weight. So number 1, the percentage of individual fraction retained by weight on sieve number 3 by 8 inches on having size 9.5 millimeter. So it is 0. Okay, so Muhammad Farhan, beta, can you hear me? Muhammad Farhan, are you in the class? Okay, Hamad Shoaib.
Yes, sir.
Okay, beta, please tell me, if this is 0, how this is 0 and how this is 100?
सर ये कम्युलेटिव परसेंटेज रिटर्न बाय वेट जो होती है उससे ऊपर जितनी भी सीव होती है उसको ऐड किया जाता है, और पिछली 0 है उसके ऊपर कुछ नहीं है तो इसलिए ये 0 है, और परसेंटेज पासेस इसलिए 100 है क्योंकि पीछे रिटर्न कुछ नहीं है, 0 है.
Zabardast. So 100 minus 0 will be 100. Okay, percentage passing, all the percentage has been passed from this sieve. Good. You have explained it very well. Muhammad Atif. Muhammad Atif has left the meeting. Bilal Ahmed. Bilal beta. Okay, Shahid Nawab.
जी सर.
Shahid Nawab beta, आप मुझे ये बता दें. It is we are getting percentage of individual fraction retained by weight is 2. If it is 2, then how it is 2 and it is 98?
सर ये इस तरह है ना कि ये देखें सर, इससे ऊपर मतलब 2 सीयू गुजरे हैं सर, तो ये इंडिविजुअल जो है सर इस सीयू के ऊपर जो रिटर्न 2 रह गया और इससे ऊपर वाले की 0 थी और अब इसकी 2 थी, इन दोनों को हम सम कर लें 0 + 2 तो 2 ही आती है, और उसमें से 98 पास हो चुकी है.
नहीं, so 100 minus 2 will become 98. Okay, 100 is the total.
Yes, 100 is the total, sir. 98 pass or 2 returning.
How much is that? So 100 minus 2 is 98 is passing. Okay, good. So similarly, this is 13. So 13 plus 2 is 15, and 100 minus 15 is 85. 25 plus 15 is 40, and 100 minus 40 is 60, and so on. Now, we are trying to calculate the fineness modulus. So for the fineness modulus, we have to add all these. इनको हम जमा करेंगे. So this is 286, और इसको 100 पे divide करेंगे. Shahid Nawab, why we are dividing it by 100?
सर ये जो हमारे पास जो रिटर्न रह रही है वो टोटल 100 रह रही है सर.
There is another guy in the class. Sayyid Azad Ali Shah. जी एजाज अली शाह चला गया. सईदुल्लाह और सादुल्लाह.
जी सर.
हारून खान. जी सादुल्लाह. Why we are dividing it by 100? Why we are not multiplying it by 100? जी बेटा तेज बोलो, ऊंचा बोलो, शाबाश. आवाज आपकी नहीं आ रही बेटा, सादुल्लाह आपकी आवाज नहीं आ रही है. Okay, anyone in the class? Anyone in
सर
the class?
परसेंटेज फाइंड करने के लिए 100 पे डिवाइड करते हैं.
Beta, this was already in percentage. So to finish the percentage, we have already multiplied this with 100. So divided by 100, so we will get the figure. That will not be in the percentage. So that's why we are dividing it
Yes,
by 100. So now it is 2.86. So it is in the range of 2.3 to 3.1. So it is closer to 3.1. So it is a coarser sand. Now, the gradation, we were discussing the gradation of aggregates, and we were talking about the sieve analysis methods. So standard test sieves are as follows. These are for the coarse aggregates. On the top, we are putting this 75mm sieve or sieve having size 3 inches, then 38, 20, and so on. For the fine aggregates, the top one is sieve number 4 or having size 4.75mm and so on. The fineness modulus limits for the fine aggregates, as I told you, that is 2.3 to 3.1. For the coarse aggregate, it varies from 5.5 to 8. Whereas when we are combining these two types of aggregates, then it varies from 4 to 7. These are the limits. Now, types of gradation. So already we have discussed with the help of diagram that gap grading is a grading in which one or more intermediate size fractions are not present or omitted. Well graded means sizes within the entire range are in approximately equal amounts. The friction at many, it will be having friction at many points, excellent interlocking between the particles, and there will be very few voids. So this is the one of the best one. Uniform gradation means a large percentage of the particles are of approximately the same size. So it will be having poor interlocking, high percentage of voids, and there will be friction at very few points of contact between the particles. Combined gradation means fine and coarse aggregates are combined. So friction will be at many points. There will be good interlocking, few voids, and this will be economical. Now the next characteristics of the aggregate is the particle shape and surface texture. The shape, angularity, and surface textures, which we have already discussed, of the individual particles of aggregates have an important influence on the workability of freshly mixed concrete and the strength of hardened concrete. As I told you, if you are using smooth aggregates, its workability will be high, but its strength will be less and its durability will be less. If you are using angular materials or rough aggregates, then its workability will be less, but its durability and its strength will be high. Shape refers to geometrical characteristics such as round, angular, elongated, or flaky. These are the different shapes. Rounded shape aggregates. Rounded shape aggregates are naturally occurring aggregates. As I told you, normally we are getting it from the river bed sides. It is fully water worn. It has been shaped by the water which is passing from these aggregates throughout the time or for a long time, are completely shaped by abrasion. For example, river or seashore gravels, desert and wind blown sand, because when this wind is also blowing and it is passing from the sand, due to passing of the sand and it is coming in contact with the sand particles, they are trying to shape it, they are trying to smooth the shape of the sand and remove the sharp edges. Then the irregular or partly rounded shape aggregates. Naturally irregular or partly shaped by abrasion and having rounded edges, for example, hard gray siliceous stones. The next one is the angular shaped aggregates, possessing well-defined edges formed at the intersection of properly planar surfaces. These are obtained by crushing the rocks, for example, crushed rocks of all types. You will see the figures in these slides. The flaky aggregates are those aggregates in which the thickness of the aggregate is smaller as compared to the width of the aggregate and length of that aggregates. For example, laminated rocks are the sheet of the rocks, both naturally occurring as well as crushed stones. Flaky and elongated aggregates are those materials which have the length considerably larger than the width and the width considerably larger than the thickness. You will see in the picture. These are the particle shape and surface textures. You can see this is the flat one, this is the elongated one, this is the angular one having sharp edges, and this is the round or smooth one. Here you can see the smooth, and this is the rough one. So coming toward the surface texture. Surface texture is a measure of relative degree to which particle is polished or dull. Smooth, if you are using smooth material or smooth aggregates, then the bond between the cement paste and aggregate is weak. When you are using rough aggregates, then the bond between the cement paste and aggregate is strong. Rough textures has better bond and tension. Importance of particle shape and surface texture. What is the importance with if we are using these type of aggregates? The particle shape and surface textures of an aggregate influence the properties of freshly mixed concrete more than the properties of hardened concrete. Once the concrete has become hardened, its properties are not that much affected by the surface textures and shape of the aggregates. But when the concrete is in fresh condition, then its properties are affected by the shape and surface texture. Rough textures, angular elongated particles increase voids between aggregate particles than do by smooth aggregates and rounded aggregates. The mixing water and cement requirements tend to increase as aggregate void content increases. If the aggregates having more void contents, then we will need more water. And if we have less aggregate void content, then we will need less water. Hence, aggregate particles that are angular require more cement to maintain the same water cement ratio as compared to the smooth aggregates. The bond between cement paste and a given aggregates generally increases as particles change from smooth and rounded to rough and angular aggregates. As I told you, this increase in bond is a consideration in selecting aggregates for concrete where flexure strength is important or where high compressive strength is needed. So when you need high compressive strength or flexure strength, then we need to use rough and angular aggregates. A rougher texture results in a larger adhesive forces between the particles and the cement matrix, resulting in a better aggregate cement bond. Now coming towards the another characteristics of aggregate, that is the bulk density or unit weight. Zabiullah, are you in the class, beta? Zabiullah.
Yes sir, I'm in the class sir. नेट प्रॉब्लम था इसलिए सर थोड़ी देर के लिए डिस्कनेक्ट हो गया था.
Okay, so now you are in the class, okay?
Yes sir, I'm in the class now. Yes sir.
Can I ask you some question?
जी sir.
What is bulk density?
Sir, bulk density. Sir, the mass or weight of the aggregate required to fill a container of a specified unit volume.
ये तो मैंने लिखा है, आप खुद बताएं.
सर खुद का तो पता नहीं सर.
Anyone in the class who can define bulk density? जी, सैयद एजाज अली शाह.
Sir, weight of the aggregate divided by the volume occupied.
Yeah, the total weight of the aggregate divided by the total volume of the aggregate, in which we are also taking the volume of the voids. Then this is called bulk density. That's why we are calling it the bulk. The bulk density or unit weight of an aggregate is the mass or weight of the aggregates required to fill a container of a specified unit volume. The term bulk is used since the volume is occupied by both the aggregates and voids. The approximate bulk density of aggregates commonly used in normal weight concrete ranges from about 1200 to 1750 kilogram per cubic meter or 75 to 110 pounds per cubic feet. Methods of determining the bulk density of aggregates and void content are given in HTM C29 or H2T19, useful to classify between light and heavyweight aggregates, converting proportions by weight to proportions by volume. Anyone in the class who can tell me H2, what this stands for? H2, AASHTO. H2 stands for American Association of State Highway and Transportation Officials. The document is T19, so all these details are available in these documents. Now, the bulk density or unit volume. I have tried to explain this with the help of these figures. So we have this one figure and we have this one figure. So let me ask someone in the class. Fahad Khwaja. Fahad Khwaja, I hope you will not leave the class.
Yes, sir.
What is the difference between this picture and this picture? जी बेटा।
सर इन ये लोअर बल्क डेंसिटी जो है सर इसमें इन प्रॉपर मेथड दे आर अरेंज एंड दूसरे वाले में हायर बल्क डेंसिटी सर लेस पोर है और इसमें पोर ज़्यादा है, इसमें पोर कम है।
See this one, it will have low bulk density. Why? Because it has lower weight. Because why it has lower weight? Because it has more spaces. It's having more wires as compared to this one. In this one, the particles are properly compact or properly packed. So it will have high bulk density because it has more weight. The volume is the same over here, but the weight is lesser as compared to this weight, the higher weight and less pore spaces. So you can see over here how the bulk density or the unit weight of material can affect the concrete. So if you have more wires, then you will need more cement paste to cover these wires. If you have less wires, you will need less cement paste. So when you are needing less cement paste, you have economical concrete. If you are needing more cement paste, then you have uneconomical concrete. Also, when you are this packed or high density or high bulk density or high unit weight concrete or high density concrete, you will be having more higher strength as compared to this one. Then once you have more higher strength, it will be more durable because it has no pores, no wires. And due to these wires, there will be the passage of it will allow the water to pass through it. And due to passage of water, it will cause dampness of the concrete. And then after some time, you will need repair of this concrete. So we should try to have properly dense aggregates, properly dense material, and properly packed material. The void content between particles affects the paste requirement in the mix design. As I told you, most natural aggregates have particle densities in between 2400 to 2900. That is 150 to 181 pound per cubic feet. The next characteristics of the aggregate is the specific gravity. So I hope you people remember the definition of the specific gravity. The specific gravity is the relative density of an aggregate is the ratio of its mass to the mass of an equal volume or equal absolute volume of water. It is used in certain computations for mixture proportions and control, such as the volume occupied by the aggregates in the absolute volume method of mixed design. When we will be studying the mixed design, we will need the specific gravity of the aggregates. Okay, most natural aggregates have relative density in between 2.4 and 2.9, but you have to perform this test in the lab and you will have to find the actual specific gravity of the aggregates which you are using in the mixed design or which you are using in the concrete. Test methods for determining relative density for coarse and fine aggregates are described in HTM C127, H2T85, and HTM C128 or H2T84 respectively. You can read these documents and you can learn the methods how we can get the specific gravity of the aggregate. The next characteristics of aggregate is the density. So the mass per unit volume is called density. The mass per unit volume of the material is known as density. An approximate value of 1000 kilogram per cubic meter or 62.4 pounds per cubic feet is often used for the density of water. I hope everybody remember this. Most natural aggregates have particle densities in between 2400 and 2900 or 150 and 181 pound per cubic feet. This will be assignment number 3 because I just give you a trial of assignment number 2 already in the Google Classroom, but most of you people have not submitted it because I told you just write the names, study and write the names. So you will be having this assignments and we will be having some more assignments so that you can get the maximum sessional marks in your this course. So I will upload this in the Google Classroom. You will have to define and explain the impact, abrasion, and crushing resistance of aggregates. Then you have to define and explain the elastic modules of aggregates. Then you have to define and explain the soundness test of aggregates. Some of them we have discussed in the first semester. Then you have to define and explain the bulking option. You just read the book and some uh, relevant documents on internet. If you have any problem, then you can contact me by email or by WhatsApp or whatever is easy for you people. You can contact me. I will upload this in the Google Classroom. Is there any question? If you people have any question, then we have to give time to the question and session. जी बेटा.
सर इधर बंद में सर नेटवर्क का मसला होता है सर, तो मुझसे सर पिछले लेक्चर बीच में सर थोड़े रह गए थे, तो रिकॉर्डिंग भी सर एक्सेस नहीं होता है, डिले होता है, तो सर अगर वो क्लासरूम में शेयर कर तो अच्छा होगा।
I have already shared the recording. क्यों आपके पास रिकॉर्डिंग नहीं आती है?
सर वो जीमेल में है सर, क्लासरूम उधर जीमेल में है सर, गूगल में एक्सेस नहीं करता सर, मैंने वो स्क्रीनशॉट भी आपको सेंड की थी।
नहीं, आपके पास यूनिवर्सिटी का ईमेल एड्रेस नहीं है?
सर है, उससे एक्सेस नहीं होता है सर, जब वो बाकी टीचर होते हैं सर वो क्लासरूम में अपलोड करते हैं सर, आपको वो जीमेल में अपलोड करते हैं वो, तो वो एक्सेस नहीं कर पाते।
ज़बीउल्लाह
जी सर, जी सर।
किसी और स्टूडेंट के साथ इस तरह का कोई मसला है? किसी और टीम के साथ है?
सर इधर क्लासरूम में वीडियो नहीं है सर, वो जीमेल में आए थे, क्लासरूम में एक भी रिकॉर्डिंग की वीडियो नहीं है। हेलो 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 हेलो
एक्सक्यूज मी सर।
जी जी प्रेजेंट।
हेलो जबी माहौल आवाज
एक्सक्यूज मी
नहीं।
सर जी। हाँ तो da سوى شو لجنك ختم شو قصة سر جدي وشو مو اللي وشو
مولا هم لي
بس
وشو
problem
زاوية
لا فتناش ده سوى ده
فتنشت مول لي وشو كان هذا مسلا وشيء.
أنا first time ده شو told you شو ترى ده okay
ज़बीउल्लाह
जी सर। सर अब पता नहीं है सर, अचानक ही हो गया।
एजाज अली शाह
सर मेरा वाला बिल
जी सर।
एजाज अली शाह
जी सर। जी सर।
ये सर वो आपको सर वो आपको सर उसको सुनाई दे रहा है।
Okay, let me stop the recording. Today we will be having the viva of group number 6, and then group number 6 students, I will request if you have no questions, then you only group number 6 students will have to remain in the class, and rest of the students they can leave the class.
Excuse me sir जी।